Good morning, good afternoon, good evening, wherever you are in this wonderful world. You're welcome to a Love My Tool TV session. We got some great guests again. Where our host today is Paul Alford of Advanced 7 over in UK. He's a pretty good guy. He speaks a little funny, but a great guy. and, and we got a boy from Texas, Keith. Actually, he's not from Texas, but that's where he's at. And we got a great visitor today from Corvil. So hope everybody has a wonderful day and a wonderful week. And Shark Fest is going on, so think about that. Yeah. Paul, it's up to you.
Okay, thanks very much, Tim. So the title of the session was the IT blame game. And let's turn to Keith first to get his view on this. What do you think about this whole subject, Keith?
Well, so it's an important subject out there, right? You know, how do you diffuse the IT blame game? There's always, issues with trying to find out where is the problem located in my network. And I've got a problem. People are telling me I've got one. Where is it? You know, who owns it then is the next thing. It's like trying to figure that out can be another issue. And then you want to go fix it. Turns out somebody's moved my stuff. It's like, who moved my cheese? Well, it's like, who moved my cart? Who moved my stuff? Where is it? How do I get a hold of it? So there's all these issues around the blame game, and finger pointing starts to happen. We've all seen it. We all know it. It goes on. It's human nature. But there's definitely some clear and I would say powerful things you can do to help mitigate some of those effects. The biggest thing is around visibility and understanding how to harness the power of visibility to see what's going on in your network and then make things easier for you. So that's what I'm here to talk about. And Scott, he's here to talk about it as well from Corvil.
Just before we go to Scott, so just picking up on that, and I know we were talking off air about the power of packet brokers, etc., and to direct the network traffic to the correct tool sets. What are the challenges around the programmable? Now we're looking at things like software-defined networks and highly agile infrastructure. Does that bring new challenges to your company and the products that you provide?
It does, but I would say it doesn't at the same time. So even in a traditional network, I think people are having problems finding out, hey, what's running in my network? Where are the problems? So they need visibility. They need to go and install taps. They need to put packet brokers in there that can aggregate the data from taps and span ports. And then they need to use that packet broker to go and fan the data over to purpose-built tools to get to a faster analysis of the problem. And they also need role-based permissions so that filters don't change, people can't change things on you, and so forth as far as the NPV programming. When you look at other contexts like SDN and so forth, you're going to have problems as well, some from the architecture, from some different types of equipment, some from, again, I would say, I guess, the architectural problems where you've got all these different bidirectional taps out there, maybe depending on what's going on, and headers and transportation of data. Again, with the packet brokers and purpose-built tools, a lot of that complexity can be reduced. You can go in and strip off the headers with a packet broker. You can do deduplication of data and aggregation of data from multiple sources within the packet broker. And now you're back down to that core set of information. You send it on to a purpose-built tool and let the tool start to do the analysis and give you a dashboard of results and data so that you can actually have some actionable intelligence.
Okay, so I attended a Gartner I&O Infrastructure and Operations conference in Frankfurt a couple of weeks ago. Big thing there was talking about, Corvil were there, of course. Oh, I think Ixia were as well, actually. Yep. Anyway, that side. One of the big things they were talking about was, of course, migration of systems into the cloud. And the prediction that by 2020, 80% of corporates will be shutting down their own data centers, which I found a pretty bold statement. But obviously, I know our customers have got cloud strategies, and I know of one big bank in the UK that's really going for it. So what about that? What do we do about visibility in the cloud?
So as far as the cloud goes, I mean, if you have performance, you have troubleshooting issues, even compliance, a lot of times you still need to get hold of that packet data. So there are tools that are out there in the cloud, but you still need to get that packet data. So you need some sort of basically quote unquote tap or an agent or a some sort of a sensor or something you can put into the cloud that'll capture the data, that'll replicate the data, and then send that over to your purpose-built tool that's on network or off network. And so that then gives you the access you need in a cloud environment. If you have a hybrid environment, you can export the data if you want. Because I was at Cisco Live a couple weeks ago, and I was talking to customers, and yeah, so people are moving to the cloud. I don't know if it's 80% because I talked to a lot of guys who said, no, we're not in the cloud right now, and we have no intention of going. And it was a lot of the government aspects and healthcare. They were worried about the PII information because there's still a lot of concern about security and performance in the cloud. And how does the cloud work? People, sort of think you can just shift and lift what you've got in the on-prem into the cloud and it's going to work the same. And it's like you find out, well, wait a minute, my IPS probably isn't going to work the same. It's not going to be a bump in the wire like it was over here on the wireline side. So now it's, yeah, there's lots of differences you got to take into effect.
Don't get me wrong. I think there's a lot of challenges coming up. And to be fair, just to qualify what I said, Gartner did say that they believe that almost all large corporates would be running in a hybrid configuration. That there would be data kept back on premise, and that's unlikely to shift in the foreseeable future. But this sounds like a good point to talk to Scott about. What do you do with these packets once you've got them, Scott? So, what I'm interested in hearing from you actually, Scott, before you start is how has this whole packet analytics progressed? I mean, we start off with basic things like Wireshark, and then we got into things like packet analyzer from Riverbed and things, and it's then it progressed. Where are we going?
So when I started off doing packet capture and packet analysis, it was a once a day grab. So the probes that I was supporting would do a push of the data, and I would be 1 day behind. Now I work for Corvil, and I have nanosecond granularity in real time. So in 15, 20 years, it really has progressed to that level. I think there is an evolution there, though, in regards to instrumentation and also sort of getting the packets first, right? First, it's can I see the packets? And I think cloud is, once again, bringing that to the forefront, which is if I have this complexity, if I have SD-WAN, how can I see all the things I want to be able to see? So we're getting creative with probes and sensors and agents and things to be able to sort of, rebuild that visibility. But then on top of the packet layer, there is a bit of intelligence. People call it analytics. People call it, the dashboard, operationalizing that data. What that really means is, can I take that that packet level detail? Can I raise it up into a more English type language to provide the user with some information about those packets? So that might be a full HTTP connection. It could be looking at a SQL query, or it could be just like TCP zero window events. So it sort of just depends. There are definitely different layers of analytics, and depending on who you are, you might care about one or not care about the other.
So a lot of people are talking about going from not just packets actually, but other machine data, raising it up to you get a view across the infrastructure, then you get a view across the application, and then you get a view across the business. It's this sort of layering of visibility layers. It strikes me that one of the challenges coming up is because we are moving into a highly dynamic situation with things like containerization and even Lambda going beyond that, but things that are run in one place, then they're run in another, and there's an awful lot of a big dynamic aspect to it. How do your tools track all of that change, and so that they can present something that's meaningful?
Well, I think more and more we need we partner with folks like Ixia, like with Keith, because the aggregation layer, 5, 6, 7 years ago, if I had a tap or if I had a switch or if I had a span port, I was good to go, right? Now with the complexities with hybrid networks and those kinds of things, I actually have to think of, okay, how am I going to be nimble? How do I get that visibility across the data centers, across the virtual entities and those kind of things? And so that ag layer becomes more and more important to tools like mine, monitoring tools, to be able to plug into there. And frankly, customers need to think of both, right? So instrumentation isn't just about the packets. It can be other things, and I think that a good approach to any type of monitoring is going to have multiple layers of instrumentation. I happen to support a tool set that does packets, so that's sort of my world. But I think that you really need to kind of understand, okay, how can I see this? Is there a different type of instrumentation, for example, that might be better for one environment over another environment, right? So for example, log files or agents or flow data might be a good source of information for one part of the network as opposed to another. So it really is just about figuring that out. And I'm not sure anybody really has it all figured out. I think it's always a challenge when I walk into customers and consult with them. I will tell you that in my current role with the financials and dealing with trading environments and those kinds of things, I am super surprised at how willing they are to tap infrastructure in between infrastructure to get a very finite, granular view of that piece. And that's because that infrastructure really matters, right? So depending on how close and how fast your digital business is going, you really want to make sure that the data is getting from point A to point B in a timely fashion. So it's always interesting, I think, when I take on a new role or go into a new customer to see exactly what their strategy is for that type of instrumentation.
Okay, so that's very, very interesting. The thing that was struck me was the other big trend, of course, is towards converting from a traditional IT operations environment where we've got development on one side of the house, we've got operations on the other. Then operations is broken down into its technology silos, and then we the proposal is let's throw that out and let's shift to DevOps and all become full stack engineers. So if there is going to be a movement in that way, where engineers are having to take a more end-to-end and full stack approach, how are you guys going to simplify the environment enough such that, say, a Google system reliability engineer can use the tools that you're providing? Is that possible, or do you think the network engineer has to exist?
Well, so the network engineer has to exist because there has to be the day-to-day keeping the lights on and sort of the day-to-day maintenance of the route switch and those kinds of things, right? So there is definitely some of that. But I think the DevOps paradigm is forcing better instrumentation, because those guys can't just get a 1 minute average and make any type of meaningful decision based off that, right? So if you're gonna blur the lines and have DevOps sort of own the stack, they really want to know, and they're smart enough to understand what it means if you give them a packet capture, or if you give them an application trace from a Java instrumentation tool or something like that, right? And frankly, I definitely see a blurring of the lines, or it has been going on for some time, of that network engineer, operations, the level 1, level 2 support personnel, and as we push up to level 1 and level 2. Better decisions, because the tools are getting better, the analytics are getting better. That basically that person is sort of becoming that hybrid, DevOps individual. I just think some companies are taking more of a more strategic approach to like brand them DevOps people, and here's the group that does that DevOps thing organization.
Yeah, but I think there's still going to be a lag. It always seems that we deploy technology before we teach people how to manage it and monitor it and protect it. If you look at all the latest deployments in the clouds, we've had like 45% more breaches already this year than we had last year, and the majority of them were major cloud breaches. So the problem is we're deploying stuff before we're teaching people how to manage it, how to care for it, how to protect it. And with GDPR, it's going to start costing companies a lot of money if they don't wake up and invest in the future.
Yeah, I think monitoring and troubleshooting has always been the sort of side thing. Like we're going to spend the budget on the bricks and the roof and all that kind of stuff, and then it's kind of an afterthought. And unfortunately, that really is kind of not good thinking, right? So if you're building the instrumentation into the data center build or the cloud migration, then you're ready. You're ready for the breach. You're ready for the troubleshooting. You're ready when what hits the fan. Otherwise, you're left going, oh well, we didn't get, it's not finished. We didn't do the monitoring, or the monitoring is in another place, and then it takes forever to sort of take that stuff, uplift it, send it to where it needs to be, and it really is it's not good.
Yeah.
No.
Yeah, and I told Paul earlier that I was in a situation where a guy was telling me he couldn't monitor certain areas of his network, and I said, I'm sorry, that's not my fault. You guys designed it that way, so now we got to go back and redesign it and fix it.
Well, and here's the money issue. I did a study for a very prominent school on the East Coast. Let's just say there were ivy on the walls, and there was no way they would admit me, right? There's no way I'd be able to get into this school. We did a study on, they had a recent event that they had gone through, troubleshooting event, and we kind of just walked them through how many hours, how many people, the whole thing, right? And at one point on their war room call, they had over 30 people on the call. They had 5 or 6 different vendors, and they had maybe 1 or 2 what I would call high dollar consultants on it. It was between $15,000 and $20,000 per hour when all those people were engaged, and they had over, let's say, 10 hours of full engagement and probably another 30 hours of sort of half of that engagement. So we did the math on it. I mean, it was astronomical amount of money that they're spending, and it was because they had lack of instrumentation. They had no plan to basically figure out when things go wrong in the environment, what do we use? And they were trying to just use whatever came with the servers, whatever came with the routers and switches and that kind of stuff. And yeah, there's some good native tools there, but if you just have the forethought to spend the dollars ahead of time for that issue, you're saving yourselves lots and lots of money in the long run. Just nobody really understands that because nobody does the math on those types of things.
That's literally the business case for a visibility architecture.
Yep.
Right there. You've got the business, the financials right there. You need to capture the data and then send it on to security, monitoring, compliance tools, and so forth. And people just aren't thinking it out. It's not that hard. It's just step back, think it out before you go and implement, and understand where you're getting your information from, where you're not getting it from, and then how you're going to get it to your analysis tools.
Go ahead, Steve.
Yeah, I was going to say, and where you're at risk, right? Because I don't think that I hate when people tell me they want to boil the ocean, or I want to see every packet in my data center, because whenever they say that, you're kind of defeated at the forefront, just because the reality of how you guys have things set up, it's not going to work. Now, however, I do think that you can put together a plan in place that here is my proactive piece, I'm covered 90%, and here's my reactive piece for the other 10, right? So but you got to have that plan and know what to do when the fire alarm gets pulled.
Absolutely, and when people build these structures, a lot of it's, the walls have already fallen down. Now I got to fix it. Oh, and I got to fix my roof because it leaks. I think Ponymon said it was 3.6 million was what it cost per average breach, and that doesn't include, the fines. And I know the federal courts, because I do a little work with them. They're starting to get to where they're fining a lot more, and they're starting to file criminal charges because the board sits there and says, we don't want to do it. It'll cost money. It'll hurt our bonus.
Yeah, and part of what Scott was just saying too. Getting access to the data, and at least in my mind, from what I've seen of the pricing, is not that expensive. It's not that hard. Get access to all of this data. It doesn't mean you use it all. You filter and pull out what you need when you need it, but just put the plumbing in, and then you've got it when you need it, and then you pick what you need, and you go from there. It's quick, simple, easy.
Yep. Yeah, and the average cost is $150 per second of breach data loss. That's the average. Think about that a minute.
I think the thing is that just picking up on something that I think Scott and Keith said, this business about not taking problems seriously, and in particular, I'm interested in things like recurring performance problems and stability issues. I know, you get big failures, something goes bang. Usually IT departments are well geared to deal with that sort of failure, but they're not so good at dealing with the recurring problems where, we're not sure which technology is causing the issue. 9 times out of 10, they'll say it must be the network then. So, that now in the past, you're right, people haven't taken it that seriously. But so the other big movement, of course, is digital transformation. Everybody believes tech, digital has got to be at the core of the business. Well, if that's true, and if you look at what Google and Netflix and Facebook and the way all these people operate, they're driven by this sort of data. And they don't, they're not going to allow problems to wander on month after month, because it's probably going to impact them really quickly and probably cost them a lot of money. And if we're all moving towards digital businesses, then that's going to be the same for everyone. And yet I still find people take a fairly laid back view to it. So if you can crack it, if Ixia and Corvil can crack it, then future's bright, guys.
Yeah, right. I think you're exactly right. I think my favorite thing to troubleshoot are connectivity and outages, because those are the easy ones, right?
Yeah.
The degradation and those kind of things, those are the really tricky ones. But you can't improve what you can't measure, right? Like there is a truth there, and if you don't have the foresight to measure that thing, you don't know when you're degraded, and you don't know if you made a change, if you've affected that thing. So and specifically on security, tool sets, DMZ is getting really complex now, right?
Yeah.
And the dynamic of the security team and the IT ops team or the network team, understanding who made the change, did it affect anything, is becoming it's definitely a black box. So being able to understand like what some of the things that Corvil does is looking at the packets and being able to do analytics on top of those packets. So the idea of, if I make a change to my infrastructure, does it stay the same, is definitely something, quite frankly, for all the tool vendors that are out there connected into the Ixias of the world and Ixia itself, right? I think is incredibly important. I'm not sure the industry or we as a whole have sort of embraced that whole idea of the measure audit. We try to do the before and after and those kind of things, but it's difficult to sort of quantify, because the before and after requires you as an individual person to set a delta or set a KPI, and that can be a little bit difficult, right? It's not just CPU memory or disk I/O. It might be multiple things that are you want to measure to see whether or not you've affected something. So that's sort of on the tool vendor side, to sort of make that easier and roll that stuff up into dashboards and complex AI and baselining and those kinds of things. I think that there's more of an evolution there to help customers see those kinds of things.
Right.
Yeah, there definitely is, even from a visibility perspective. See, because you got the packet data, but then as someone mentioned earlier on, I think it may have been you, Scott, that there's flow data. There's all these different types of data. So you can go in and look at flow data. You can capture information, geolocation, application information, and this flow data, and then go and analyze that. So if you're looking for application slowness, some application performance problems, you may not have the information to go in and diagnose what's actually happening within the application and the problem there, but you can diagnose that, hey, it's in this network segment and it probably looks like it's this application running. So now you've got, again, actual intelligence to go focus your effort. Instead of trying to look at the whole network, you've zeroed down to the right area you need to focus on, and you can do it lightning fast.
Yeah, and one of the neat things is that a lot of times you can't fix the problem immediately, but you can circumvent some of the issues that it's causing. So a lot of times by getting down to the root, you say, hey, that's going to cause, I'm going to have to do this, 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 and this. But in the meantime, I can change this and make it a little better. Okay. But the thing about Corvil, I was going to mention is Corvil comes when Dr. Lewis started Corvil back in the 90s, I think it was, they were focused on stock markets. Actually, originally they worked with the London, the UK stock market and the Dublin, the Irish stock market. And when you're looking at a heritage of a company, you want someone that has done that. And boy, trust me, you think about several $100s per second for our industry. Think about trading industry, how even a few seconds can cost millions of dollars. So
Yeah,
the pedigree of Corvil is from that arena.
Yeah, so our standard is that a single packet missed is potentially millions of dollars lost. I mean, that's our paradigm for what we do.
Yep. And that comes from dealing with security and trading.
Yeah.
Okay, if we just going back to the title of the show, that's to diffuse the IT blame game. So one of the things I'd put to you guys is that at the moment, especially with what you've been talking about, it seems to me that by default, if there is a problem and you don't know what's causing it, then networks are going to get the blame. And so what you're actually saying is, it's not about how to diffuse the IT blame game, it's how to enable the network team to do a more effective and quicker handoff to the correct team. Because that's really what you're talking about, isn't it?
Well, it could actually be both in my mind. I mean, yeah, where's the problem? How do we locate it? But then it's like, who owns the issue? So is it the IT team, the admin team? Is it the security team? Is it the performance team?
No, I agree. So it's
which one owns it?
Yeah. So it's that handoff. But you're never going to convince me that you're going to get a server guy or even anybody from IT service management to look at packets or anything.
No, you're exactly right. You need to put it in a format that everybody in the table can understand, a common language for everybody to understand. And I will tell you that the person with the best data wins in those situations. So the blame game is always going to take place because we have different teams. They're always going to look across the cubicle to the guy next to them and say, "Hey, it's your fault, not mine." It's almost human nature, right? However, if we can enable the teams to have a common language that says, "Hey guys, you're always blaming the network. Let me show you why it's not the network. You know, here's the data, empirical data there. Now we're on the right critical path." I think it's more important to be on the right critical path than the mean time to resolution. You know what I mean? Like a lot of vendors talk about the 3 clicks and we nail your issue. Well, that's ridiculous. That never happens, right? But if there are 3 paths into the woods, and I can basically tell you that path 1 and 3, there's likely nothing at the end of them. Yeah. Fine, we'll go down 2, and it's a collaborative thing in those war rooms for the blame game to be able to see that. But without the proper instrumentation, without the proper documentation, and I don't want to sit there with guys that say, "Hey, my gut instinct tells me it's that server thing again, or it's the virtualization thing again, or the whole thing." That's just, it's not good. It's not productive.
No, it's open to all sorts of sort of biases and what have you. So you hear a lot of people talking these days about mean time to innocence, don't you? I'm sure you've heard that term.
Oh yeah.
And so based on what you've said, and we've talked about the importance of that network data to achieve this sort of guidance, if you like, you are hanging a lot on the future of network engineers. And I think you said earlier, Scott, that you said, well, network engineers will live on forever because somebody's got to maintain the routers and the switches and all that stuff. And I have to tell you, I'm not convinced, because I think provisioning, configuration, and all that type of work is becoming very simple, or potentially could become very simple, like a point and click type of environment. If you look at some of the tools, I saw a Riverbed demo. Sorry to keep talking about Riverbed. It's just that I saw this demo of a provisioning tool that they have. And that looks like an admin job to me. And the other thing is that you hear a lot about people using disposable infrastructure. So I believe it's Google now use really cheap servers that they have manufactured in Taiwan. And if one goes wrong, they unplug it and chuck it in the bin. And I can see that we may end up with a very utility style of networking. And I'm not convinced that you're going to need those sorts of skilled people to manage that environment.
Yeah, I don't disagree. I think that the challenge there is that, or the sadness, I guess, is that the very smart technical engineer who really understands how networks work, that is becoming less and less prevalent in the environments. But you still need them to troubleshoot. Like you have to understand the underlying basic way that things communicate, things get routed, things get switched, to be able to really understand what may be causing problems. And if they're just admins because they're just setting up the SD-WAN and letting the software do all those pieces, it's kind of like back in the day when VB came on board and the C++ developers were all complaining that there was all these widgets that were self-contained. You need to control it yourself. It's kind of that same evolution, and it's probably there's nothing to stop it. Except maybe we've got to be more intelligent with the tool vendors to be able to make sure that we can expose that information and sort of go with that admin type person.
So that
what I've been doing this a long time. I started out in the 70s, excuse me, doing diagnostics on WANs. That's helped build the first datascope. And I've heard this argument, Paul, about we won't need people pretty soon. And I disagree. I just don't believe that we're ever going to get to the point to where we don't need the rational ability of people's, the capability of interpreting many different facets of data. Because I remember AT&T and saying we're not going to need Datex anymore once we get the new data speed 40s up, and oh gosh, I can't tell you how many times I've heard that. So I just don't believe that's ever going to happen. I think we're going to broaden one individual's reach.
Yeah.
Being able to handle more things, but I just don't ever see that people will not be needed to run networks, to diagnose, to support anything.
Okay, so I'd make 2 points on that. So in support of what you just said, of course, that Tesla have been struggling with the manufacture of the Model 3, and Elon Musk said, I think we've underestimated the capabilities of humans versus machines.
That's right.
So I guess that might be a warning for the future for us. And the other point I'd make is in 2013, I attended my first Shark Fest at Berkeley, and I did a session there. And at the end of the session, I told the network engineers that I believed that the pure role of network engineering would diminish, but that they were needed to help other teams troubleshoot problems, because they were the only people who really understood how end-to-end systems worked. And I still believe that. I don't think you're doomed if you're a network engineer. I think you're doomed if you think you're going to sit there configuring Cisco switches for the rest of your days, because I agree with that. Yeah. But if you are prepared to step outside your comfort zone and get involved in a broader spectrum, and Gartner have coined this term versatilist. If you're prepared, it doesn't really trip off the tongue, but that's what they told everyone. What's needed are versatilists. I mean, if you are a network engineer and you are prepared to get involved in other areas, I think your future's really bright for you, because I do think, Advanced 7 uses network packet analysis all the time, but we hardly ever look at network problems. We're looking at the interactions between components in a system. And and network engineers are great people to understand that. I just don't think you're going to be programming switches. Yeah. Okay.
Heck, Paul, I can program a switch. Well,
Yeah. That's all right. Good. We'll keep you in reserve.
That's right. Just in case, right?
We'll fly you in when we need you. We just fly all over the world.
I'll do it remotely. Now I can do it remotely. So, anyway. But I mean, all this goes back down to one thing we started out with is visibility. And visibility is the foundation of all knowledge. If you can't see it, you can't touch it. A friend of mine named Tom Tosh once said that networks are like people. We need to know what their temperature is, what their blood pressure is, just like when you go in for a physical. And that is the key to understand the dynamics and to be a successful diagnostician, in my humble opinion.
Yeah, without that visibility, you can't fix it, you can't secure it, you can't do anything.
I think that underpins it. I think the speed of data, the data rates, and the rate of change within a modern IT environment is so great that you're going to need tools such as those you get from Corvil, because the idea of you just capturing packets, obviously you can't do packet capture and analysis real time anyway, not a human can't. So, those sorts of solutions are going to be important. And the other thing I would raise is it's all very well generating data of any type, but it's actually understanding how to read that data and provide insight into what's going on. And I think that is lacking big time. You know, I'm sitting in front of a Windows PC at the moment. It's got, I think, out of the box, this thing generates 630 streams of diagnostic data in ETW events. And I doubt anybody looks at a tenth of those or 1% of those, you know? So the data's there. It's just, we need to figure out how to make sense of it. And we need to figure out how to make sense of it very quickly. And in that way, we'll be able to stop the IT blame game.
Hopefully.
Yeah. Okay. Great session, guys. Really good. I enjoyed that. So, Tim, you got any final thoughts you want to wrap up with?
Well, no, first off, I want to thank Stephen coming from Corvil. Keith, it's always nice to have you here. I always tell people when you look at a company to help you, always look at where they come from, their foundation, their founders, and you know what makes Corvil or any other company say that we're able to do this. Well, Corvil's got a great history, and it is from Ireland, so it's got to be good. Sorry, Stephen, I had to say that. Okay, so, but no, thank you for coming, Stephen. I look forward to maybe some articles from you. I love my tool. Keith, take care. Paul, thank you again for everything.
Okay, good stuff. I'll stop the broadcast. Thanks very much, guys.